So the objective of this meeting is to go through chapter 10. Okay. And so here we have the review. All right. And in chapter 10, we're talking about conics, three in particular: the parabola, the ellipse, and the hyperbola. Okay. So to start off with the first example here, it says select the correct choice. So I'm assuming that if this was the test, that let me see if I can just unclick this. That was not good. That was not good. That was better, I think. So the idea is that there's probably going to be some multiple choice answers here. So I kind of deleted the multiple choice so that we can go ahead and go through the work here. All right, so if we're looking at the equation of a parabola, and what I'm looking at here in this particular picture is that this parabola, the vertex is not at 0, 0. So in this particular case, since it is opening up, it's going to be of the form x minus h quantity square 4 times a y minus k. This will be the equation of a parabola that opens up, okay? There will be an equation that opens up whose vertex happens to be the point h comma k. Okay. Now, for example, let's say that on your exam, you have a situation where the parabola is opening down. Okay, and this will be the vertex. So in that particular case, we're looking at a parabola of the form x minus h quantity square negative 4a y minus k. Okay. For example, let's say that we're talking about a parabola that is now opening sideways, let's say in this direction, okay, in this direction. Then in that particular case, it is the y minus k term that will be squared. Since it is opening to the left, then I'm going to introduce a negative 4a x minus h. Now, I've written three particular equations, and we understand what x is. That will be the independent variable. Let me look here. The independent variable, the dependent variable, h comma k will be the vertex. But what is a? A in a parabola is the distance between the vertex and the focus. So if I'm looking at this particular picture here, this is what we call A. It turns out that this line right here is called the directrix. Turns out that this distance from the vertex to the directrix is also A. So moving on to question 2. If A is equal to 4, in other words, this distance from here to here is 4, then what is the coordinates of the focus? Well, in this case, the x value will remain the same. So the focus will have an x value of 3, but it will be 4 units up from 2. So that will be 6. All right, so example 3 says, find the equation of the parabola described below. Find the 2 points that define the lattice rectum. Oh, that's fun. And graph the equation. Okay, so it's telling us that the focus is at 7, 0, and the vertex is at 0, 0. I think before I even get there, okay, I'm going to take this information and put it on the graphing grid. All right, so let's see if I can use some colors here. Maybe it'll make things a little bit better. Let's see. Hopefully, I won't make a mess out of this. All right, let's see. Let's see what's up with this blue. So it's telling us that the focus is at 7, 0, or right over here. And I'm going to label that as F for the focus. And it's telling us that the vertex is at 0, 0. Now with this information, okay, it is enough for us to say that this will be a parabola that is going to be opening to the right. And you're probably wondering, why is that? Because the parabola will pass through the vertex and it somewhat hugs the focus. Look at this picture right here. It passes through the vertex and it somewhat hugs the focus. Same idea here, here, or some of the examples that I poorly drew on there. Okay, so I know that this parabola will be opening to the right. So it will be of the form, because it's opening to the right, y squared is equal to 4ax. And you're wondering, well, where's the h and the k? Well, the reason why we don't see h and k is because the vertex happens to be 0, 0. So what is a? A is the distance between the vertex and the focus. So in this case, we can agree, hopefully you and I can agree, that A is equal to 7 units. Okay, so what's the big deal? Well, what's the big deal is that now we can actually come up with an equation. All right, so we have y squared is equal to 4 times 7 times x. Oops, I don't know if you guys can see that. Where's the mouse? Okay. So y squared is equal to 28x. This is the equation of the parabola. The directrix will be also, in this case, 7 units to the left of the vertex. So here is the directrix. And the directrix has equation x is equal to -7. All right, let's see what I think I need to just maybe put some here. Y squared is equal to x. The 2 points that define the lattice rectum. Okay. The points that define the lattice rectum will be the points that pass through the focus or are aligned with the focus. That's what I should have said. Are aligned with the focus. So the parabola is going to open in this direction. And so therefore it will intersect this line twice, up here and down here. And these 2 points make up what is called the lattice rectum. But they are aligned, they are on the same line as the focus. What does that mean? These 2 points will have the same x value, 7. Okay, so if x is equal to 7, y squared is equal to 28 times 7. Y squared is equal, I'm not that good with math, so I'm just going to go ahead and use the calculator here and, save ourselves a little bit of time. We got 196. Take the square root, so we get a positive and a negative solution. I'm using the calculator here. 6. What is, 14. Oh, nice. Oh no, I just broke my leg. So what happens is that we get 2 points. That points will be 7, 14, and I don't even know if you guys can see that. And 7, -14. Those will be the 2 points that will make up the lattice rectum. So 7, 14, I think is here. I'm going to call that P1, P2. Those will be the 2 points that will define the lattice rectum. And so therefore the parabola will pass through, again, it will pass through the vertex. It will look something like that. Let's pause the video. Here we want to find the equation of a parabola. They want us to find the 2 points that define the lattice rectum, and they also wants us to graph the equation. The vertex is at 5, -6. That's the first thing I'm going to do. 5, -6. 5, -6. Right here. And I'm going to label that as V. And the focus is at 5, -7. Oh, 5. Oh, they could have not made it any closer, huh? Wow. Okay. And so what happens is that, again, the parabola will pass through the vertex, but it will hug the focus. So that means what this is telling us is that this is a parabola that opens down. This is just like a quick, shading sketch. I was just kind of giving myself an idea of what it looks like. So it will open down. So it will be of the form, check it out, x minus h quantity square is equal to negative 4a y minus k, where in this case h comma k is the vertex. So for this example, the vertex is 5, -6. So we have x minus 5 quantity square is equal to negative 4a y plus 6. Recall that a is the distance, the number of units the focus is away from the vertex, or the number of units that the directrix will be away from the vertex. In this case, I know it's kind of poor to see, but the vertex and the focus are 1 unit away. So A is equal to 1. So negative 4 y 6. That is the equation of our parabola. Now in this case, when we want to find the points that define the lattice rectum, again, those 3 points must be on the same line. So, okay. So in this particular case, what we need to do is we need to input the value of y, which is in this case -7. So we need to solve the equation x minus 5 quantity square -4, what was it, -7 plus 6, because y is equal to -7. Because the focus has a y value of -7. Okay, so let's see if we could do this. We got x minus 5 quantity square -4. This would be -1. This is just 4. I'm going to take the square root out of both sides, and we get x minus 5 is equal to +2 and -2. Adding 5, we get that x is equal to 7 and 3. So those will be the 2 points that will define the lattice rectum. All right, now let me do my best attempt at graphing this. Oh, 7, -7, and 3, negative. I think I did a decent job there. All right, let's hit pause and see if there's any questions. It says a satellite dish is shaped like a paraboloid of revolution. The signals that em- emanate from a satellite strike the surface of a dish and are reflected to a single point where the receiver is located. If the dish is 16 feet across at its opening and 5 feet deep at its center, at what position should the receiver be placed? When you read this type of examples, what I'm trying to define here is where should we put the focus? Where should we put the focus? So the strategy for this particular example is that this dish can be simulated with a parabola. So we're going to give ourselves a parabola, not just any parabola, but a parabola that is centered at, well, I'm sorry, whose vertex will be a 0, 0. Okay. It says that the dish is 16 feet across. So therefore, here we have 8, and here is -8. From here to here will be 16 feet. So it is telling us also, so that the satellite dish looks like this. It is telling us that it's also 5 feet deep. So I think what I want to say is at its center is 5 feet deep. But I don't want to label that point in any form or shape because that's not the focus. Okay. It's just telling us that the order pairs here, of course, I could have done better there. That these order pairs are of the form 8, comma 5 and -8, comma 5. So continuing with this particular example, we notice that this is a parabola of the form x squared is equal to 4ay because its vertex is at 0, 0. If we are able to find a, then we'll know how many feet should we place the receiver or the focus away from, in this case, the vertex. Okay, so our job here will be to find a. Let's see. This point is of the form x comma y. So, oh, we can plug in the value of x, we can plug in the value of y, and solve for a. Let's do that. A squared is equal to 4a times 5. That is a squared. Let me just write 64. That is 64 is equal to 20a. A is therefore 64 divided by 20. And since it is an application problem, I would like to know how much this is. And this is beautiful, 3.2. So the focus of this parabola is 3.2 units away, or 3.2 feet above the vertex. So this is where the receiver should be placed. The receiver should be placed 3.2 feet above the vertex. All right. What we do is we should make all the way up here is 5, so that looks like 3.2. Right. It says that select the correct choice that completes the sentence below. So I'm assuming this is going to be a multiple choice question for an ellipse. Oh, Now we're changing gears. For an ellipse, the foci lie on the line called the. Okay, so I don't think I need this anymore. So now we're talking about an ellipse. So let me just give myself a simple picture here. And so the ellipse has a center. I wonder if I'm recording. I don't, yes, I am. So it has a center. This thing always gets jacked up. All right, here we go. It has two foci. Focus one, focus two. It has two vertices. Vertex one, vertex two. Okay. And so it will look something like this. The ellipse will pass through the vertices. Okay. Not through the foci. And so this line that contains the foci, that contains the center, that contains the vertices is called the major axis. It's called the major axis. The line that is perpendicular to the major axis and passes through the center, which in this case is that right there, is called the minor axis.
So if your focuses and your vertexes were on the y-axis, would the answer be the minor axis?
No, it will always be the major axis.
Okay.
So the line that contains the foci, center, and vertices will always be labeled the major axis. So what you're referring to is an ellipse that looks like this. In that case, the y-axis is the major. Let me put it, will be the
Oh,
major axis. Got it?
okay. Yes, sir.
All right. So couple of notes here. The distance from the center, to a focus, this distance from here to here is what we label as C. So I'm going to label here center, but this distance from the center to the focus is labeled as C. The distance from the center to a vertex is what we label as A. Therefore, there is an equation related to the ellipses, which says E square is equal to A square minus C. And if you're wondering what in the world is B, B is this distance right here, where the ellipse will be where it will have its biggest width, where it will have its biggest width. All right, so let's see what we could do with this information and try to answer question 7. Okay, so the answer here was major axis. So in number 7, we have the equation of, oh, I didn't write, okay, we'll fill in some information in a minute. But here's the equation of an ellipse where the value of A is blank, the value of B is blank, and the major axis is also blank. All right, so let me let's add a couple of notes here. If the ellipse is on its side, if it is on its side, and the center is at 0, 0, then it will have the following equation: x squared over a squared plus y squared over b squared is equal to 1. If we have an ellipse whose major axis is the y-axis and it is centered at 0, 0, then that ellipse will have the following equation: x squared over b squared plus y squared over a squared is equal to 1. The idea here is that a is greater than b, okay, for both of these situations, okay? So if the biggest number is under the x term, the ellipse will be it will be laying on its side. If the biggest number is under the y term, then the ellipse will be standing up. In this particular example, okay, I realized that the biggest number is under the x term, so that gives me the hint that it is laying on its side. So a squared is equal to 25, then a is equal to 5. B squared is equal to 9, therefore b must be equal to 3. And the major axis in this case will be the x-axis. Number 8 says, if the center of the ellipse is at 3, -4, and the major axis is parallel to the x-axis, and the distance from the center of the ellipse to its vertices is 5 units, then the coordinates of the vertices are blank and blank. I think what I'm going to do is I'm going to just give myself a picture of what this information is telling us. So it's telling us that the center is at 3, -4. 1, 2, 3. 1, 2, 3, 4. It says that the major axis is parallel to the x-axis. Oh, okay. What that means, oh, I'm sorry, my apologies. You can do that. Let's see. The major axis must run this way. Make sense, yes or no? So it is in the major axis that we'll find the vertices, and we will also find the foci. Not only that, the fact that they're telling us that the major axis behaves is a horizontal line, that means that the ellipse must be of the form x minus h quantity square a square, because it is laying on its side, plus y minus k squared over b squared is equal to 1. So it will be of that form. All right, so it says that, let's see, that the vertices are 5 units away. Okay, 5 units away from the center. So, oh, that puts it at 8, right? And then 5 units away this way. Can we say that that's -2? So the vertices will have ordered pairs 8, comma, -4, and -2, comma, -4. So from here to here is 5. From here to here is also 5. All right, I think we answered that. It says, find the equation. Oh, here we go again with this auto nonsense. All right. Number 9, find the equation of the ellipse whose center is at 0, 0, and focus is at -12, 0. Oh, and a vertex at 15, comma 0. Okay. Let's put all of this information on an X and Y axis. The center is at 0. Okay, that's actually not bad. This is the center. And then you have a focus at negative 12, 0. So here's a focus at negative 12, 0. And a vertex at 15, 0. Oh, okay, all the way out here. Okay. 15, comma 0. Oh, with that being said, that means that the other focus must be on this side, the other vertex will be on the other side, and therefore this ellipse will be laying on its side. Okay, so where do we find the other vertex? Well, if
Uh,
it is, yeah, go ahead.
oh no, negative 15, 0.
That's right, that's right. Negative 15, 0. And help me out. Where do we find the other focus?
12, 0.
That's right. Oh, yeah. Well, I meant to put here 1. And so that will be 12. So the ellipse will look like this. What do we need to do? We need to find the equation. Okay. So we need to find this distance called b, or that width b. So since it is laying on its side, it will be of the form x squared over a squared plus y squared over b squared is equal to 1. The distance from the center to a vertex is what we call a. So that will be 15. The distance from the center to a focus is called c, and that is 12. And with that information, we can solve for b. B squared is equal to a squared minus c squared. B squared is therefore equal to 15 squared minus 12 squared. B squared is equal to, I'm not even going to entertain this, straight calculator work, 81. B, well, actually, okay, fine, we'll find B is equal to 9. So we know that this point right here will be 0, comma 9. And this point right here will be 0, comma negative 9. But we need b squared for the equation, so we have x squared is equal to 50 squared plus y squared over 9 squared, which is equal to 1. And so x squared over 225 plus y squared over 81 is equal to 1. Find the center. Here we go again with this auto thing. Why does it do that? Find the center, foci, and vertices of the ellipse and graph the equation. By the way, I remember that like these type of examples, you are selecting the right graph. Okay, so it will be multiple choice on the graph. So you don't actually have to graph it. You just gotta select the right graph.
One question for the
Yes.
when we do our answer sheet, right? That we have to do when we do the test. Do you want us to graph it there?
No, there's no need. There's no need. Just do all the work. Or if you have some kind of sketch or something like that, then do that. Okay.
Okay, thank you.
All right. So number 10, we have the following ellipse: x minus 1 quantity square over 9 plus y plus 3 square over 16. I'm noticing that the biggest number is under the y term, so this must be an ellipse that is standing up. Okay. whose center is going to be 1 comma negative 3. So I'm just put that on a sketch here. X, Y axis. We have 1, negative 3. So here's the center. Since it is standing up, I'm expecting the the foci and the vertices to be along this line right here. Okay? Because it is standing up. So in this case, a squared is equal to 16 and b squared is equal to 9. Therefore, a is equal to 4, b is equal to 3. In this case, what we're saying is if this is the center, 1 comma negative 3, the vertices are going to be 4 units away from the center. 4 units away. That puts one vertex here at 1 comma 1. And it puts another vertex 4 units below, which that will be negative 7, 1 comma negative 7. So there are the coordinates of the two vertices. To find C, we have the equation b squared is equal to a squared minus c squared. To find C, c squared is equal to a squared minus b squared. Why do we need to find C? C will give us the number of units that the foci are from the center. So A was a squared is 16 minus 9. That gives us 7. So C is equal to the square root of 7. Uh-oh. So this is not going to look pretty, but it is what it is, okay? So what's happening here is that there will be two foci, one here, one down there, and their coordinates will be of the following form. I'll use a marker. So the x value stays the same, but the y value we will add square root of 7. That's for the first foci. For the second foci, we keep the same x, but in this case, since we're moving it down, instead of adding, we will take away the square root of 7. So those will be the two the two ordered pairs that correspond to the foci. And b is equal to 3, so therefore that will be 3 here. Okay, so I obviously didn't do such a good job. Well, maybe. All right, something like that. Okay, my graph is poor. My graph is poor. Number 11. Oh, here we go again. Says analyze the equation, that is, find the center, foci, and vertices of the ellipse. Graph the equation. Okay, let's see if we can do all that here. Let's try to use all of the space that's available. We got, okay, 48 x squared plus y squared plus 24y is equal to 0. This looks nothing like the equations that we're familiar with, so this is what we're going to do. Okay, we're going to group the y terms together, and we're going to complete the square on the y terms. Cannot really complete the square on the x terms because it is only the x squared term. There's really nothing we could do there. Okay, so we have to complete the square, 24 divided by 2, 150 squared
It's 144.
is 144. Thank you. So we have 48 x squared plus y squared plus 24. Whoa, 24. 24y plus 144 is equal to 144. If you're wondering why, we added a quantity of 144. We must also add the same quantity on the other side to keep equality. Then we have 48 x squared plus, this is factorable, and it factors into y plus 12 quantity squared is equal to 144. We now divide by 144 because all of these equations, they have to be equal to 1. So we'll divide by 144. And we'll get in this case up here x squared over 3 plus the quantity y plus 12 squared over 144 is equal to 1. So this represents an ellipse that is actually whose center is 0, negative 12. It is standing up. It is standing up because the biggest term, the biggest number here, the biggest denominator is under the y term. So all right, I guess we need to find some more information here, huh? So a squared is equal to 144. A is equal to 12. B squared is equal to 3. B is equal to the square root of 3. To find the foci, we need to find C. So B squared is equal to A squared minus C squared. 3 is equal to 144 minus C squared. 144 on each side. I ran out of room here. We get negative 141 is equal to negative C squared. C must be equal to the square root of 141. All right, well, that's pretty interesting. I think I need a white paper here to kind of sketch. So here's the example fully worked out. Kind of forgot to record all the other steps in between. Number 12 says, find the center, find the equation of the ellipse given the following information. Okay, it is giving us the center, it's giving us the vertex, and it's giving us 1 point on the ellipse. Okay, well that's fun. That's gonna be fun. So let's plot the information given. The center is at -3, -4. The vertex is at 2, 2, -4. That means that this ellipse is going to be laying on its side. Okay. And so, okay, well, with that being said, I can find the other vertex. So this would be 2, 5. So 5 units this way, that's -8. Which is at, in this case, -8, -4. Okay, because in this case, this distance from here to here was 5. Okay, so we have an ellipse of the following form. x minus h quantity square over a square because it is laying on its side plus y minus k quantity square over b square is equal to 1. Okay, so we have the vertex is the center is -3 so we have x plus 3 quantity square over 25 plus y plus 4 quantity square over b square is equal to 1. We don't know the width yet, or the most width. So therefore, we're going to rely on the fact that since it passes through the point -3, 1, this will be the x value, and that will be the y value that will satisfy this equation. In other words, we'll plug in the value of x, we'll plug in the value of y, and then we can find the value of b. Okay, so let's go ahead and do that. Or we'll find the value of b squared. Okay, so here we have okay, so plugging in -3, 1. So we get 0 squared over 25 plus 1 plus 5. So that will say 5 squared over b squared is equals to 1. This term goes away because it's 0. So 25 is equal to b squared. 25 is equal to b squared. So find the equation. Okay, so the equation is x plus 3 quantity square over 25 plus y plus 4 quantity square over 25. Oh, that's interesting. This is a circle. Okay. But there it is. There's the equation. A hole 150 feet in length is to be designed as a whispering gallery. If the foci are located 40 feet from the center, how high will the ceiling be at the what is it? How high will the ceiling be at the center? Okay. So similar situation here. A whispering gallery is a gallery whose um gallery is in the shape of an upper half ellipse. Okay. So what we're going to do is we'll take our information and put it on an y axis. So we'll put the center at 0, 0. Since the hole is 150 feet, then I'm going to label this 75. And of course, that will be -75. So the gallery will have this shape. Right, this upper half ellipse. It will have this shape. So if the foci are located 40 feet from the center, so 40, here's where we find a foci. Here's the other foci.
So you're trying to find B?
Yeah, we're looking for B. That's right. We're looking for B. So therefore, this must be of the form, since it is centered at 0, 0, and it is laying on its side, x squared over a squared plus b squared over b squared. Y squared over b squared is equal to 1. In this case, this was a very useful piece of information. This was a very useful piece of information. And why is that? Since they're telling us that the foci is 40 feet away from the center, that means that C must be equal to 40. This distance from here to here is what we know as A, is 75 feet. Therefore, with that information, we can say B squared is equal to 75 squared minus 40 squared. B is going to be the square root of 75 squared minus 40 squared. And I'm just going to use the calculator here. I'm not going to entertain this, but trying to do it by hand. And we get approximately 63.4 feet. The ceiling of the Whispering Gallery is approximately 63.4 feet.